About 3.5 million tonnes of nitric acid are made each year in the UK. Most is used to produce ammonium nitrate fertiliser. Ammonium nitrate is also used in explosives. Nitric acid is used in the making of nylon and for polymers that are used in sports clothing and swimwear. ICI makes about 1/4 of the UK's nitric acid on its Billingham site on Teesside. Much of that acid is used by ICI or by companies nearby. The raw materials are ammonia and air. In the converter, nitrogen monoxide is formed. This is cooled and reacts with more air to produce a mixture of nitrogen dioxide and dinitrogen tetroxide. These gases are absorbed in water to produce nitric acid. At the Billingham site, liquid ammonia is fed to the evaporator here. Ammonia is mixed with air here and passes to the converter. This is the absorber. Liquid ammonia is fed directly from the ammonia plant, which is close by on the same site. It is evaporated in this vessel using heat from the hot water produced later in the process. Air, the second raw material, is drawn from the atmosphere and compressed to a pressure of about 5 atmospheres. Filters are used to remove oil and dust from the air, which could poison the catalyst used later. The streams of air and ammonia are mixed here and passed to the converter, also called the burner. This is just the top of the ammonia burner. Inside the burner, the gases produce heat as they react to form nitrogen monoxide and steam. The reaction is catalysed by a gauze of platinum and rhodium. In the burner, the catalyst is supported by a steel mesh. This is a spare steel mesh. The catalyst gauze, made from platinum and rhodium, is very valuable. Replacement gauzes are kept securely in locked safes. Catalyst gauzes are changed every 3 to 4 months. The woven metals become poisoned and are returned to the manufacturer to be recycled. The reaction in the converter produces heat. The gas stream leaving the converter is cooled by water. This produces steam, which is used to drive a generator. In the gas stream, the nitrogen monoxide is oxidized by excess oxygen to a mixture of nitrogen dioxide and dinitrogen tetroxide. The mixture passes to the base of the absorption tower. The tower contains a number of slotted trays. The gases rise up the tower and through the trays. Water runs down the tower. A reaction occurs to produce an approximately 69% solution of nitric acid. This is the equation for the reaction. The reaction is exothermic. It produces heat. The blue pipes contain water that is used to cool the acid stream in the tower. The acid that falls to the bottom of the absorber is green-coloured because it still contains quantities of nitrogen oxides. In this tower, the green acid is swept with air to remove the nitrogen oxides. The resulting acid is colourless. The production process is monitored and controlled remotely from a control room. Small, carefully monitored amounts of nitrogen oxides are discharged from the stack. Most customers require the 60% or 69% acid. More concentrated acid is produced by removing water with sulfuric acid. About half the nitric acid is used on site and half transported by tanker.